We're asked to find the area of this shaded region, but remember what integration tells us. If we're integrating the function 1 plus cosine of x, this red curve, then it's going to tell us the area between the curve and the x-axis. So integration won't directly give us the right answer, but what you could do is you could say, hey, this big area is just a rectangle. It's pi across and 2 up, so the big area is 2 pi. And so to find out the area of just the shaded piece, let's find out this red area that I'm shading right now with integration, and we'll subtract that from 2 pi. Here, let's change the color. Okay, this area in blue. So we want to subtract the integral from 0 to pi of the function 1 plus cosine of x. And then when we do that, you're taking the big red area that I shaded, subtracted by the blue area, that leaves us with the black shaded area like we wanted. So we just need to follow the rules of integration, we'll be all done. So we can integrate term by term, but remember this entire integral is being subtracted, okay? So we want to protect whatever our result is with the parentheses, so we distribute that minus sign. And so I'm going to use the linearity property of the integral operator, which just means I can break it up term by term. I can do the integral from 0 to pi of 1 with respect to x, plus the integral from 0 to pi of cosine of x with respect to x. So that's 2 pi subtracted by this antiderivative of 1 is just x, and then the limits of integration are 0 to pi, right? Because the derivative of x would make 1. And then the antiderivative of cosine of x is just sine of x. And then the limits of integration, a straight line like this, okay, 0 to pi. But this whole thing is still in parentheses, right? I'm subtracting this entire integral, and this is the entire integral inside here. So I've got to figure out what this is and then apply the subtraction sign. Okay, so using the fundamental theorem of calculus, I'm plugging in pi into my antiderivative, and then I subtract what happens when I plug in 0 into the antiderivative. That's this first one. And then it's plugging in pi into my antiderivative, by what happens when I plug in 0 into my antiderivative. So pi minus 0 is just pi. Sine of pi, if you want to know how to do that without a calculator, pi is 180 degrees, and sine represents the y coordinates on the unit circle. So here's a 180 degree rotation. This is at negative 1 comma 0. So the y coordinate is 0 there. So sine pi is 0. And same thing with sine of 0. That would be right here. It also has a y coordinate of 0. Finishing this out, we got 2 pi minus pi. So the final area is just pi.